Okay, when you verify each identity, what you want to do is work with one side until you get exactly the other side. So I tend to work with the sides that look more complicated. So the left-hand side is sine of theta. I want to write these in terms of sine and cosine. So I have sine of theta times cosecant of theta. So cosecant of theta is the reciprocal of sine, so I can write cosecant as 1 over sine. So this turns into sine over sine, which is 1, which I have showed that the left-hand side is equal to the right-hand side. Okay, the second one, definitely the left-hand side is more complicated. So what I'm going to do is I'm going to write these out in terms of sine and cosine again. So secant squared is going to be 1 over cosine squared theta minus 1 over cosine squared theta, because that's secant squared theta times cosine squared theta. So then this turns into 1 over cosine squared theta minus, these two will cancel out, so I'll just have 1. So anytime you're adding and subtracting with these trig expressions, you want to get a common denominator. Just like when you're adding or subtracting fractions, you want to get a common denominator. So in this case, I'm going to have the common denominator of cosine squared theta. So this is going to be cosine squared theta over cosine squared theta. So using the Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1, if you subtract cosine squared theta from each side, you'll get 1 minus cosine squared theta. So sine squared theta is 1 minus cosine squared theta. So look at this numerator here. 1 minus cosine squared theta. This is going to be 1 minus cosine squared theta over cosine squared theta. Well, cosine squared theta, or 1 minus cosine squared theta, is sine squared theta. So sine over cosine is tangent squared theta. So I proved my identity. Simplify each. So I'm going to write them in terms of sine and cosine. So secant is 1 over cosine theta times cotangent, which is cosine theta over sine theta. Well, the cosine and cosine will cancel out, so you get 1 over sine theta, which is the same thing as cosecant theta. And then sine theta times 1 over cosine theta times cosine theta over sine theta, because cotangent is cosine over sine, secant is 1 over cosine. Sine and sine cancel out, cosine and cosine cancel out, so it's just 1. That's simplifying. Okay, 42, solve each equation on the interval. So this tells me that my answer needs to be in radians, and I need to include from negative 2 pi to 2 pi. So solve for sine of theta. So sine of theta equals 1/2. So on the unit circle, sine is 1/2 at a 30-degree angle. So in these two parts, it's going to be a 30-degree angle. So this will be 30 degrees and this would be 150 degrees. So you want to convert each one of those into radians. So 30 degrees is pi over 6, and then 150 degrees is going to be 5 pi over 6. So you also want to include the negatives. This is telling us we need to include the negatives too. So we need to think about what would we call this angle that's going negative. Well, that would be negative 7 pi over 6, because that's negative 210 degrees. And this one would be negative 330 degrees, which is negative 11 pi over 6. So all of these angles need to be included. Okay, and then this one I'm going to add. I'm going to have 2 cosine of theta equals root 3. So where is cosine of theta equal root 3 over 2? So where is cosine root 3 over 2? Well, that's going to be a 60-degree reference angle. So the 60 degree in the first and fourth quadrants, because cosine is x and x is positive in the first and fourth quadrants. So I'm going to have 60 degrees and 300 degrees. So converting to radians, it's going to be pi over 3 and 5 pi over 3. But then I need to think about the negatives too. So negative 60 degrees is going to be negative pi over 3, and this would be negative 300 degrees. So negative 300 degrees is negative 5 pi over 3. So just make sure that you're looking at the interval, whether it's degrees or radians, and whether it's all real numbers, or you're going to have to add plus or minus 2 pi n or plus or minus 360. In this case, we got a interval here. Find the exact value of cosine of 105. So what you're going to want to do is use your formula sheet, and so the cosine of 105 is going to be the same thing as the cosine of 60 plus 45. So you want to look at your formula sheet of doing cosine of A plus B. Okay? See my key on that. And then number 44, sine of 15, you're going to want to do the sine of 45 minus 30, which is going to be the sine of A minus B. So look on the formula sheet of what you do with sine of A minus B. And then see my key. 45, find the specified value in each triangle. So think about whether you can use SOHCAHTOA, which is right triangle trig, or law of sines and cosines. So I always try to do SOHCAHTOA, the right triangle trig, but I can tell on this one I can't, because it doesn't have a 90-degree angle, so I can't just set up a ratio. So to figure out what angle C is, I need to do 180 minus 43 minus 99. So this is 38 degrees. 38. And then to find CB, so I'm trying to find this. I can't use a trig ratio, sine, cosine, tangent, but I can try the law of sines. I always try law of sines first. So law of sines, I have enough information because I can do the sine of 99 is to 12 as the sine of 43 is to CB, or I'll just call it x. And then cross multiplying gives us x sine of 99 equals 12 sine of 43. Now, because we're talking about degrees, you need to make sure that your calculator is in degree mode. So change it. So if you've done a different problem that you were in radian mode, change it, double check it to make sure you're in degree mode. So do 12 sine of 43, close the parentheses, and divide it by sine of 99. And you get about 8.3 if I round the nearest tenth. Okay, AB is, I can't use SOHCAHTOA because it's not a right triangle. So I try law of sines. I'm trying to find AB, so I do sine of 37 is to C, and then I don't have any other angles, so I can't do that. So I'm going to use law of cosines. So this angle, this is a side angle side situation, so it's going to be C squared, because this is this value right here, equals 11 squared plus 8 squared minus 2 times 11 times 8 times the cosine of 37. So again, you want to be in degree mode. So to solve for C, you're going to take the square root. So I'm going to put this in my calculator. So I do second square root, or second x squared, which is a square root symbol of 11 squared plus 8 squared minus 2 times 11 times 8 times the cosine of 37. So it's approximately 6.7. So for the next one, I can use SOHCAHTOA because it's a right triangle. And I'm trying to find the measure of angle A. So if looking at angle A, you can actually use any one of the three trig ratios, because I could do the sine of A, which is 12/13. I could do the cosine of A, which is 5/13, or I can do the tangent of A, which is 12/5. But either way, I have to do the inverse, because whenever I'm trying to find the angle, I need to do the inverse. So I'm just going to do the sine. So I'm going to do the sine inverse of 12/13. And I'm going to have my calculator in degree mode, and that's going to give me an answer in degrees. So it's about 67.4 degrees. In this next one, I cannot use I can't use the SOHCAHTOA because it's not a right triangle. Law of sines, I don't have any angle, so I can't use law of sines. So I have to use law of cosines. So if I try to find this angle, then my c squared is going to be 10 squared. So 10 squared plus equals 12 squared plus 8 squared minus 2 times 12 times 8 times the cosine of L. So just be careful when you're doing this one that I would add up 12 squared plus 8 squared first and get 208 minus 2 times 12 times 8 is 192. So a common mistake is people putting these two together, but they're not like terms. So I'm going to do 100 minus 208, and I get negative 108 equals negative 192 cosine L. Divide both sides by negative 192. And so you're trying to find this angle measure. So whenever you're trying to find the angle, you have to do inverse. So actually I'm going to put cosine inverse of this in my calculator. Just to keep it quicker, I'm going to drop off the negatives, because a negative divided by a negative is a positive. So 108 divided by 192 is 55.8 degrees. So just make sure that you're careful and intentional about this part, that you're not combining these. And then the last one, find O and A, or A hypotenuse in the opposite. So in this case, I'm going to do the tangent to find the opposite, because I have the adjacent. So I'm going to do the tangent of 34 equals O over 18. It's kind of a weird variable because it looks like a 0. But I'm going to do the tangent of 34, close the parentheses, times 18. So this is about 12.1. Now I don't really want to use 12.1 when I find the h, because I just rounded it. So I'm going to use the cosine of 34 equals adjacent over hypotenuse. So multiplying both sides by h will give you h cosine 34 equals 18. So h equals 18 divided by the cosine of 34. So 18 divided by the cosine of 34 is 21.7. So this is 21.7.